Physics is really getting complicated. I really feel for the children in high school, senior high school, and college with all these new particles that have been found. The laws of physics may need rewriting after surprising particle discovery baffles scientists. The physics may need rewriting because of the precise measurement ever made of an elementary particle called the W boson. We know this from the CERN findings, and it's revealed to be heavier than expected under the standard model. W bosons are elementary particles. They're named for the role they play in mediating the so-called weak force, one of the fundamental interactions alongside electromagnetism, gravitation, and the strong force that holds protons and neutrons together to create the atomic nucleus. The weak force, which acts instead of the individual protons and neutrons, is important because it underlies various forms of radioactive decay and underlies the nuclear fusion process that powers stars like our sun. Various efforts have been made previously to determine the exact mass of the W boson using data gathered from high-energy particle physics experiments, including the Tevatron Collider and the Fermi National Accelerator Laboratory of the Fermi Lab near Chicago, Illinois. Researchers with the Collider detector at Fermilab, it's called CDF. Presently, 400-strong group of experts have been calculating increasingly precise measurements of the W boson for more than 2 decades, and their latest estimate is based on data on some 4.2 million W boson candidates. They were detected in the aftermath of high-energy particle collisions with the Tevatron from 1985 to when the machine ceased operations back in 2011. The data was around 4 times larger than the one used by the collaboration in its previous calculations of the W boson back in 2012. The study lead author, particle physicist Professor Ashutosh Kotwal of Duke University said, "The number of improvements and extra checking that went into our results is enormous." He says, "We took into account our improved understanding of our particle detector, as well as advances in the theoretical and experimental understanding of W boson's interactions with other particles." He said, "When we finally unveiled the result, we found that it differed from the standard model prediction. In the standard model, the mass of W boson is linked to the measurements of masses of 2 other particles, the top quark, and which was first spotted by the Tevatron Collider at Fermilab in 1995, and the Higgs boson particle, the detection of which was reported at CERN LHC, Large Hadron Collider, in France, Switzerland in 2012. Using these masses as a starting point, the standard model predicts that the W boson should have a mass of 80,357 MeV C2, which is roughly 80 times the mass of a proton. The latest analysis of the Tevatron data, in contrast, places the W boson mass slightly larger at 80,433. And according to the team, this measurement comes with a precision of 0.01%, a 2-fold improvement on the last best estimate, and the equivalent of measuring the weight of 800-pound gorilla to within 1.5 ounces. University of Oxford physicist Professor Chris Hayes, who's a member of the CDF collaboration, said the CDF measurement was performed over the course of many years. The measured value, he says, was hidden from the analyzers until the procedures were fully scrutinized. And when we uncovered the value, it was a surprise, he said. The researchers explained that the new value is in agreement with a number of the previous efforts to pin down the mass of a W boson, but in disagreement with others. Fermilab Deputy Director Joe Leakin said, "While this is an intriguing result, the measurements needed to be confirmed by another experiment before it can be interpreted fully." CDF spokesman and high-energy physicist Professor Giorgio Chiarelli of the Italian National Institute for Nuclear Physics said, "Many collider experiments have produced measurements of the W boson mass over the last 40 years. These are challenging," he said, "complicated measurements. They have achieved even more precision. It took us many years to go through all the details and the needed checks. It's our most robust measurement to date, and the discrepancy between the measurement and expected value persists, he said. Fellow CDF spokesperson, high-energy physicist Professor David Toback of Texas A&M University, said that the collaboration's latest finding is an important contribution to tests of the accuracy of the standard model. He said it's now up to the theoretical physics community and other experiments to follow up on this and shed light on the mystery. He said there's a difference between the experimental and expected value is due to some kind of new particle or subatomic interaction, which is one of the possibilities. There's a good chance it's something that could be discovered in future experiments. And the findings were published in the journal Science. And this is on Express UK by Ian Randall. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.